Okay, so lesson 4.4 deals with the fundamental theorem of calculus, and there's actually two that we have to talk about. So this first one tells me that if I have an integral from a to b of this function f of x, what I can do is find the actual integral of that and then plug in that b value. Then I can use that same integral and plug in that a value and subtract those two, and then I end up with the actual area under the curve. So let me show you kind of what that means with these. So this one, if I do the integral of x squared minus 3, I remember add 1 to the exponent, so that would be x to the third, and then take your coefficient and divide it by your new exponent, so that'd be 1/3 up front. And then minus this one, because there's no variable there, that would give me a variable to the first. And then again, if I take 3 and divide it by 1, I still get 3. So I have 1/3 x to the third minus 3x. If I take that, here's the notation that they usually use. So I'm going to take that on the interval from 1 to 2. Okay, so I've done my integral part, but now I got to plug in my 2 and my 1. So first, let me plug in 2. So I'm going to take this exact equation, plug 2 into it. Then I'm going to take that exact equation a second time, 1/3, and plug in 1. And then I'm going to evaluate those two things. So this first one, this would be 8 divided by 3, or 8/3, minus 6. And I just did that on a calculator. I end up with negative 10/3. And then this one minus this right here would give me 1/3 minus 3, which would be negative 8/3 if you make it improper, or negative 2 2/3 if you make it a mixed number. These two cancel each other out. So really I'm taking negative 10/3 plus 8/3, which is negative 2/3. So that's my final answer on that one. The second one, this one, I'm not real fond of how that's written. I would rather write this as 3x to the 1/2. So that's how I'm going to integrate it. So again, when I do my integral, I'm going to add 1 here. So this would make that x to the 3/2. And then I'm going to take my coefficient and divide it by my new exponent, which was 3/2. And then I'm going to do that on that interval. So first, let's figure out what is, let me kind of separate these up here. I'm going to, oh, sorry, somebody knocked on the door. So let's divide this out first. 3 divided by 3/2. That's the same thing as saying 3 times 2/3, which is just 2. So this is really 2 with 4 plugged in right here. So this would be 4 to the 3/2. And then I'm going to subtract the same equation, 2 with my x to the 3/2. This is now 1 to the 3/2. All right, so 2 times 4 to the 3/2, that's going to give me 4 to the 3/2 is the same thing as saying I'm going to take 4 cubed, and then I'm going to square root that. 4 cubed is 64, and the square root of that is 8, times 2 is 16. And then this would be 2 times 1 to any power is just 1. So 2 times 1 is 2, which gives me 14 as my final answer there. All right, then let's do this last one here. So now we've got a trig function to deal with. This trig function, when I take the integral of secant squared, I get tangent. So this is really the tangent of x from 0 to pi over 4. So that means I have the tangent of pi over 4 minus the tangent of 0. So again, I'm taking my integral, and then I'm plugging in b, and then I'm plugging in a, and then I'm subtracting those two. All right, so the tangent of pi over 4 is 1, and the tangent of 0 is 0. Something that you should probably do if you don't have those memorized is make sure that your calculator is in radian mode if you're dealing with radians there, which we are in that case. So just make sure you don't mess that up. If it's in degrees, you're going to get some weird decimals there. Okay, So that's the basic idea of the fundamental theorem of calculus, but let's kind of apply that to something else here, something that you might have to actually visually see. So this one gives me an absolute value equation. When you have an absolute value equation, you have a situation where it's going down like this and then back up. It's a V shape. So you're finding, if you have an interval from A to B like this, you're finding two separate areas. So we have to separate it up into those two things. This first one would have a negative slope. This one would have a positive slope. So I really have to be careful here on this type of a problem. So I'm going to show you how the book actually graphed this one for me. What you could do is use a graphing calculator, or you could use Desmos, or you could just sketch it out by hand. So I would just check the points in your interval. So maybe I'm checking in this one 0, 1, and 2 and seeing what's happening to my graph. But at some point, this one's going to hit the x-axis. And where that happens in this case is at 1/2. It's at a fraction. So I need to find the negative of this side over here and then the positive of this one, because this one has a negative slope, this one has a positive slope. So what the book tells me to do is separate this up into two functions. The negative one for when it's less than 1/2, and then the positive one when it's positive 1/2, or when it's greater than 1/2. Notice on this one, they put a negative on the outside of the parentheses, because if you look at this equation right here, this line, I have a y-intercept of +1. So this would be a +1 instead of a -1. This one, if I go down, my y-intercept would be -1. So just watch what you're doing on those two things. So I'm going to separate this up. This is really, I've got an equation of -2x plus 1 when it is less than 1/2. And I have this equation that they gave me, 2x minus 1, when it is greater than or equal to 1/2. Okay, so I'm going to separate that up into these two integrals then. So I've got the integral from 0 up to 1/2 from here to here of that first one. So -2x plus 1 dx. And then I'm going to add on the area of the second one, which was from 1/2 up to 2, so from here up to here, of the original equation, 2x minus 1. Okay, so then I'm going to actually evaluate those. So this one, when I do the integral of that, I get an x squared right here. And if I divide my coefficient by my new exponent, that gives me a -1. Plus, right here, I have an x. And I'm doing that from 0 to 1/2. Plus, now I'm going to do this one. This one would be x squared. And if I take that 2 and divide it by my new exponent, I just get a 1 right there. So I don't have to put that. And then minus an x right there. And I'm going from 1/2 up to 2. Okay, so when I plug in this one becomes a -1 times a 1/2 squared plus a 1/2, and then minus, plug in your zeros. So -1 times 0 squared plus a 0. So there's that first half. The second half over here, I'm going to do my 2 squared minus 2 minus my 1/2 squared minus 1/2. And then I just got to evaluate all of this. So the good thing about this one, this piece right here is just all zeros. So that kind of goes away. So this should be easy to come up with. So this is -1/4. If you square that, that's 1/4 plus a 1/2. And then this over here is 2 squared minus 2 would be 2. And then this would be minus, this would be a 1/4 minus a 1/2. Now remember, be careful with your parentheses there, because all of this is grouped together, meaning I have to do that before I subtract these two. Same thing with this one. I have to do this before I put them with those. Okay, so this one gives me a 1/4 plus a 2 minus a, this would be a -1/4. But this becomes plus then. So a 1/4 plus a 2 plus a 1/4 gives me really 2.5. Or I could say that that is 5/2. Maybe if you did that all on a calculator, it would give it to you as an improper fraction. Either one is fine. Doesn't matter. So it's a lot of calculation from there. Okay, so then example 3, this type of a problem is asking me to find the area of the region bounded by the graph of 1/x, y equals 1/x, and the x-axis, and these vertical lines, 1 and e. Okay, so what they're telling me when they give me some vertical lines to talk about, they are giving me my bounds, my interval, right? So if you're looking at the x-axis, they're saying go from here up to here. So if I had to write this as an integral, I would say this is really the integral from 1 up to e, because that's those two bounds that they gave me, of this equation, which is 1/x dx. Okay, so then I'm going to rewrite that. Let's go ahead and do the integral. So remember the integral of 1/x, let's remember back to our derivatives. The natural log of x, the derivative of that is 1/x. So the integral of 1/x going the opposite direction is the natural log of x. And again, I'm going from 1 to e. So this is just from this to this is really just like a memorization thing, or you could go back to your front cover in your textbook and it has those listed. Okay, so that means I have to do the natural log of e minus the natural log of 1. Again, if you don't remember those, go to your calculator. But the natural log of e is 1, and the natural log of 1 is 0. So I end up with 1 as my answer there. Okay, the next two, there's a theorem and a definition here both. So the mean value theorem is talking about this idea that, so we've talked about mean value theorem before, but this one is for integrals. They're saying that there does exist some number c, so some position f of c, where it will give you the average here. So let's say I've got, I don't know, this. And remember we had those rectangles that we were adding up areas on? They're saying if I find this c value right here, that will give me my average or my mean value. So f of c that they're talking about here, and we don't use this theorem a ton in this lesson, but here we talk about it a lot. So this really is that f of c value. So your average value of the function, which they're finding in this way, really gives me this height right there. I'm going to call that h. So it gives me this height right here. So f of c. So I'm going to call that f of c just so that you kind of know what I'm talking about there. So this isn't necessarily giving me an area, it's giving me a height. So it's a little different. Okay, so this one says find the average value of this function on this interval. So this is pretty cut and dry because they're telling you exactly a formula for this. So my area would be if I took my my average value. I'm just going to leave it as, I'm going to call it average value. You could say f of c. Okay, so that's going to be my 1 over b minus a, which in this case is 4 minus 1. And then it's the integral from 1 up to 4. That's, again, this is my a, this is my b. So from 1 to 4 of my function, so my f of x, which is 3x squared minus 2x dx. So then I'm going to actually evaluate this. So this is 1/3, and then I'm going to do my integral. So my integral would be x to the 3rd if I add 1 here. And then if I take 3 divided by 3, I get 1. That would be my coefficient, which I don't need to put. Minus, this would be x squared if I add an exponent. And again, my coefficient divided by 2 would give me 1. And I'm going from 1 to 4. Okay, so here's how I'm going to do this one. I would find all of this part right here, and then at the very end, multiply it by 1/3. So I'm going to take 4 to the 3rd minus 4 squared. and then minus my 1 to the third minus 1 squared. Okay, so that'd be 1/3 times 4 to the third minus 4 squared would be 64 minus 16, which is 48. Minus 1 to the third minus 1 squared is still, no, not 1, sorry. It's 0, because this would be 1 minus 1. So really I'm just finding 1/3 of 48. 1/3 of 48 is 16. So 16 is what that was that height that I was looking for. So if I was looking at those rectangles and adding up all of those little rectangles, the height of the one that gave me the average there, the height of this one is 16. Okay.